everybody. So happy to be here today. Thank you for coming. Do you remember, probably your parents do, remember those good old days at the office where you could just work without hearing people arguing at the background? How are you using Google Anti-Gravity? No, I'm still using Cloud Code. Whoa, you should switch. It was released last week. They could just work. And all of this thanks to a kind of annual gathering. They were gathering, usually in an hotel, and they were being updated on everything that happened in their industry in the last year. I like the Hebrew word for it, ishtalmut. And that's very nice because it's kind of a firmware update, right? You're updated, come here, come to the hotel, yeah, that's it. You go out and you're just all caught up. And this is what I hope to achieve today, kind of recap you on everything remarkable that happens, well, at least most of the remarkable things that happened on the testing space in React. And question to ask is, what's wrong with the existing tooling that we have, right? We have a very rich and mature ecosystem of testing tools. What's wrong? What should be improved? So I want you to consider this UI. Okay, we have a typical e-commerce store, and we have a shopping cart. Now you are being tasked with testing this, removing a product from the cart and adding it to the wish list and craft a wish list screen. How would you test it today? I would argue that you have two main options, and each one of them is suboptimal. Each one of them leaves you with severe downsides. Let's compare them. On the y-axis, we have how much performant and feature-rich it is, how much the developer's experience of it. And on the x-axis, how production-like, how realistic this test option is. And to begin with, I think that I would frame Playwright, the popular Playwright here, right? It's reputable, it's mature, it's great. It's like production, right? It's a black box. You just put it up and it acts like your code in production. Great. However, it was never meant to be a real test runner for developers to test components and to serve you during coding. It's meant to be a better Selenium. Think about features like mocking, coverage. You don't have all of this out of the box. You have to do plumbing, which is usually time-consuming. Also, performance, it's mediocre. I benchmarked 15 tests of a page, lasts 40 seconds. Running for all the pages, long minutes, to say the least. It's okay, but it's not something that developers will run often during coding. On the other side of the spectrum, we have the most popular, still the most downloaded package in the React space. Can someone help me? What is it? I think that I heard the React testing library, still the most downloaded, which is kind of standard, a unit test-like testing framework that gives you all the feature you would expect for, right? Like coverage, mocking, also performance is much better. I benchmarked 15 tests in only 9 seconds. It gives you a better developer's experience, but it runs in Node.js with a fake browser, which means that when you have a test failing, this is what you get. HTML in CLI, no browser, no network top, no console. And if you're the type of person who like watching HTML in CLI, I definitely want to have a beer with you after the talk, so please approach the stage. I think that it's safe to say that a minimum standard now for testing is being visual, is a visual element and running in the browser. And there are other testing inefficiencies today. Usually, for teams to get full confidence, you have to deal with these 5 tools and frameworks, a lot of mental overhead. API interactions. How do we ensure that we are aligned with the APIs, that we are using the right schema, that we are safe from breaking changes? In the industry, there are a lot of tools, but none of them is baked into the JavaScript tooling. And also, developers report that writing page level or huge component tests are very time consuming because you have to do a lot of stitching, huge DOM and networks, a lot of work. Now you may say that some of this is nitty gritty. Okay, it's not like big deals, but now in the era of agentic testing, any blind spots that you have, any area, any component that is not tested is a room for some agentic coding that produces code and can put hallucinations into your code. So, welcome 2026, almost. A bloom of new testing tools and techniques might help us to achieve to score better in this regard. And I asked in WhatsApp, in one of the groups that I joined recently, not sure if you're familiar with it, the front-endist team, it's a great one. I asked, what should I cover? Which topics are you intrigued by? And number 4 was the enhancement in the StoryBook test runner, so great, we have it. Number 3, people asked, can you show me a full workflow? How do you handle testing from start to end? And yeah, we will touch a little bit also on this. Number 1 was a feature that was released last month, probably this is the reason, Playwright agents. And number 3 is Vitest browser mode, and we will start here in Vitest browser mode. So what Vitest browser mode is about, look at this test. I want to test here that when removing a product from the cart, that shopping cart, remember, in the print screen, then we call the backend delete API, and there is a toast, and so on and so forth. So I don't want you to read it, just feel it. Look at key lines here. If you ever wrote a React testing test before or Playwright, it all looks very much the same. And this is the premise of Vitest browser mode. Take your React testing library, the most popular testing framework this day, and just use it almost as a drop-in. Go to your Vitest config, and as is, just add one element, browser, and instruct it which browser do you want, Safari, Chromium, which provider, an engine that under the hood will interact with the browser, usually Playwright, and this is what you get. Visual tests that run in the browser. On the left side, the test list. In the middle, the view of the component. On the right side, additional information like visual regression showing you print screen of before and after, but we will skip this. So you might wonder, okay, so what? I do have visual. I can run this day test in the browser and get visual using Playwright or something. And you're right, but here are some differences. For a start, I'd like to show you the performance, how it feels like. Okay? So I'm about to click on a test now, and please be prepared because it's going to be a little fast. Single test, click, it renders a whole page, and that's it. It was so fast that actually I have to edit the video, and now I'm going to play it in small motion. So an entire page is being rendered with all the products. We click on the callouts, remove the product, and call the backend, and all of this in 200 milliseconds. I think that's a new level of performance, definitely comparing with Playwright. Now let's run all the tests in the page. You have a timer on the right. It's 9 tests, I think. Yeah, and it's 3 seconds for 9 tests. Visual in the browser, all the layer, the state, everything, router. That's good performance. So that's something that maybe developers would like to run often during coding, maybe even your main browser. Not only this, you could test using Vitest now almost anything. Hooks, functions, unit tests, components, everything in a single suite. Everything runs in the browser. Mocking, coverage, anything that all your features from your test runners are here. You lose nothing. All the goodies from the Vitest world. Now, I know that by now I sound a little bit like a salesman. And yeah, I want to show you I want to show you the price. I want to get deeper and show you the price of Vitest browser. So supposedly it meant to be here, like no compromises. You get both great experience, but also production line in the browser. But once we get deeper, there are some caveats to be aware of. Let me show you. Look at this test. Oh, I don't have screen. Now I do. Look at this test. They are about to fail. They are very trivial tests. There are no tricks here. The first one is move from cart to the wish list. The second is delete from the cart. So what the test does, the first one, is first we navigate to the shopping cart. Then we click on a specific product adding to the wish list, navigating the wish list, and boom, failure. Why? The test is okay, syntax is great. Okay, second test starts to run because the first failed. We navigate to the cart, try to delete it from the cart, but then failure. Why? And to explain why, I want to get a little deeper under the hood and explain just a little bit how Vitest browser mode works, because it's very different from Playwright. So for a start, you have the main thread. It's Node.js, just like Playwright. So you invoke it, and it is tasked to run some specific file. It will use the Playwright library and ask it, hey, please, can you open a browser for me? Then it opens the browser and loads a tester page. Vitest includes a tester page with two main parts. One of them is the orchestrator, a component that is meant to communicate messages with the main thread. The second one is the test runner inside an iframe. And then, second step, the main thread asks from the orchestrator, hey, can you run this file for me? File.1.test.yes. The orchestrator says, yes, sure. I'm about to approach the test runner. It's exactly, by the way, the test runners that you're using if you're doing Node.js testing using Vitest. So the test runner will start running, and if you're trying to render something, it will just render it on the screen. This is what makes it visual. Now note something that is very different from Playwright. The tests themselves runs in the browser. In Playwright, the test runs in Node.js. It's only your UI. But here, the tests run in the browser, which means even your unit test and hook testing, everything is in the browser. And this will come with a price very soon. Also, there is one iframe per test file. And there is no isolation between tests. All the tests gets the same iframe and same page. So once you understand this, I think we're safe to get back here and explain that when we try to navigate here to a different page, this is not allowed because the test runner is in the page. It's one event loop. Test runner and your code are on the same DOM, same main thread. So if you try to destroy the page and navigate, no, you have to start mocking, use navigate, and handle all of these concerns. Why did this test fail? Well, if you remember the first test, put in local storage that this product is moved to the wish list. But the local storage is shared between tests. Everything is shared between the tests. There is no isolation. So once the second test tried to find the product, it wasn't there. It's already in the wish list. In other words, it's your responsibility to take care for isolation and cleaning up, cookies, router, everything. And you have to set up the router. If you render one component, set up the router. In other words, you have now to do more effort on implementation details. With Playwright, you just take it up. It's your real application. No need to tweak anything. But here, you do need. So we have on the table now two options, right? What about the third one? What about StoryBook? Before I start, 10 seconds recap about what is StoryBook. It's a framework to display your components and share them with your team. And this, for example, is my sign-in form. And this is the shopping cart. Now, it also includes a simple test runner. So you can write a play function, and it will show you visually, see here in interaction, all the steps of the test. So I can go step by the way, Vitest browser mode doesn't have it. Step by step, timeline travel, and it can fail and show me failures. So it's kind of a test runner. But many people do not consider StoryBook a real test runner. It is not getting this honor. And there is a reason, and at least there was a reason. The way it works is very different from typical test runners. So you cannot run it in your IDE, can debug it. If you want to run it in CI, you have to get a StoryBook browser and then test over the browser. And for this reason, it was not considered a contender in the testing space. But now there is significant change here. Now you can. Now a StoryBook test is like a Vitest test. There is a feature called portable stories, and under the hood it is being converted to a Vitest test. So now I can run it I can see it in my IDE. I can debug it. I have actually all the features of Vitest. Why? Because under the hood now, StoryBook uses Vitest browser mode. So see, we have a consolidation of technologies, and I can definitely consider it as a reputable. Not only this, StoryBook has unique features in the testing space. See here, when I click Run Tests in StoryBook, or I can run it in CI, I get all sorts of testing in one user experience, in one screen. So I can run visual tests. I can get automatically accessibility testing. No need to write any new test. I can get coverage for my functional test. I can test my components. All of this in a single interface. In other words, I think that StoryBooks is a strong contender more than ever to consider in your testing strategy. Did you notice we have here a matryoshka? StoryBook is using Vitest browser mode, which itself is using Playwright. And which one should you choose here? What should be your testing strategy? So let's keep this question and visit it in the end. What type of testing strategy can you form? But at least you understand now the main considerations and differences between the technologies. So great, we have testing in the browser now, better test. But what I hear often from developers is that it's very time demanding to write component and page testing. And yeah, think about it. When you write unit, it's easy, right? But when you write component test, you have to deal with big JSONs and the design system, and logic is distributed not in 3 files, but rather in 30 or 50 files, and network calls and libraries, tons of work to stitch together. Sometimes I work hours just to make one integration test work. So you might suggest, okay, what's the problem? Let's use AI, right? Let's give an AI agent to plumb all of these pieces. And no, it won't work, because for the exact same reason, the context here is too big. There are so many pieces. There are things injected into the DOM. There are third-party and second-party libraries and networks. So many things can go wrong that AI will definitely struggle if you just ask with a prompt. It's a long ocean of risk. And what I want to show you now is how can you achieve it? How can you reduce 70% of human involvement time here? Now, why would I say that? How do I know that you would save 70%? Well, first take it with a grain of salt. But I already conducted 2 real-world projects, big system, brownfield system, with teams. And using the right agentic features, we were able to cut 70% of human testing time. And this is also a great opportunity to show you a new Playwright feature that was released last month that's called Playwright Agents. Before we get up to speed, I'd like to define our holy goal, our main goal. Things that when you structure your agentic testing flow, you want as your main metric, minimize fluff human involvement. Anytime a human, a developer, has to rescue the AI agent, to fix things, to debug testing, to help it, that's an issue. The more the human is involved only in critical steps, in planning and reviewing, that's the win. How do I achieve it? Let's see some technique. For a start, I said that definitely this is how you should think about your next workflow. Coding, testing, whatever. First, we have a spec phase where you instruct the agent to code some feature. Then a tech plan. Your agent will produce a tech plan. By the way, this is here a great time to ask for when then a test to-do list and you to review it. This is where tests are being defined. Then we have a breakdown into tasks, coding phase, of course, and review. But how do I know that this is now the only way to think about a developer workflow? Well, if you look at all the tooling in the agentic coding space, all of them, they are different in many dimensions. They have different features, but all of them share the same backbone, spec, plan, and task. All of this list. It is now even baked into Cloud Code, so we have full guarantees that this is how we should plan. And what we want eventually in the code phase, that we can ask the agent, hey, please write great tests, please with important and a lot of exclamation mark, but you know that it won't work, and you need to provide it with a skill. A markdown file that allows it to answer the key questions and knowledge about testing. In Cloud Code, its skill is more than a markdown file, but in other platforms, you could just put a markdown. And you instruct it about things like, hey, these are your test commands. This is how you plan test cases. This is your testing best practices. By the way, if you need a boilerplate for testing best practices, with AI, I created a repo, Golden Testing Rules for AI. It has more than 60 testing best practices. More than 60 testing best practices that you can consider. And I think that it's obvious that this document is critical. The quality of testing is bounded by this document. But even if it's perfect, you will face the following typical failures. Looking at the timing, things that I'll skip 1 or 2. Okay. The first one is this. You have everything great knowledge, everything perfect, but then you get this. Have you ever encountered this? Perfect, all tests pass. I said, okay, yeah, the test passed, but an hour after, I realized that, yeah, it just made skip. It just added skip to test. It didn't lie, it's a white lie. So how do you prevent this? How do you prevent it from not writing tests or cheating with tests or I think that the secret sauce is in your task phase. Each user story must start and end with writing a test. And in your review phase, that should be an independent agent that is inspecting that indeed what was defined in the spec is what is implemented. So in other words, your task list, auto-generated task list, is looked like as follows. See, we have 2 user stories, and each one of them starts with a test definition. It goes to the test file and put test to do. Now, why it is important? Because now your testing agent at least has the testing in mind. The first thing on the context it understands, it's the testing. Yeah, you have to satisfy this. It's a great start. Then we have development tasks, and each story ends with clear task. Ensure the test pass and run the test auditor. In other words, there is a clear definition of done. Testing is not a request, it's not a rule, it's a task in the list. I'll skip this one because I see that we are a little bit challenged by the time. And there will be other failures. Other failures related with the enormous, huge context that the test need to understand. And this is a great opportunity to introduce you to the Playwright testing agent, a new features released by Playwright last month. To use it, you just have to run this command. No need, by the way, you don't need to use Playwright in your project at all. You take your project as is without testing at all, just run it, and this is what you get. 3 agents in your IDE. Cursor is not supported. Guess why? Microsoft loves them. And basically what they do, all of these agents, they interact with the Playwright MCP, interact with your browser, and provide various functionalities, like test planner that investigate the page, analyze it, and create a markdown summary with test. The test generator, that as the name implies, will actually code the test. And the test healer, my favorite one, this one is beautiful, which will get failing test and try to save the day automatically. So I want to skip and show you the, I want to skip the test planner that generates a very nice report with network calls and console log and give much more context. But I want to skip all the way down to this use case. So consider this, I got in the review phase a message all test pass. And they really passed. All great. But when I looked at the code, at the log, I noticed this, that there was some failure. And the testing coder was not aware why the tests are failing. It tried for a long time, but it wasn't aware why. So I looked at the file, and I tried to understand what happened there. And I noticed that there is some call to the API. And the address of the API is not in the code base, because we inject it in environment variable. So the coding agent that can look only at the code has no idea what is the backend API, what is the backend route, address. So he tried to come up with something and say, hey, yeah, that looks sensible. Yeah, maybe it's shopping cart API. Let's try it out. Well, obviously it didn't work. And it was fair enough to just put comment on all of this code and say, hey, there is no such call, so you probably don't need it. I'm going to skip it. And I noticed that. But then it realized that there is a new agent, the Playwright test healer. And he tried to call him. I don't know what it called the Playwright test healer. And what the Playwright test healer does is it kicks in, it runs your tests, it realizes failures, and then it has a new MCP tool that's called pause and debug. It will run the test in a page, and at the minute of the failure, it will capture a snapshot of network, console, everything, and bring back to the LLM. Hey, LLM, you have now much more information. So now the LLM gets this. This is the real network call. There are things that happens only on the runtime, right? So now the LLM could be aware, okay, this is the real network calls. And the test healer was able to fix it. He just went to the code with the LLM, fixed my code, and saved the day, only because it is bringing in aware of runtime information. And I think that this is one of the beauties of an efficient test, an efficient AI coding. I got this. I didn't have to handle this. I got all test pass. And because there was auto-remediation and ping-pong between agents before that. I wanted to move to another feature. If you saw, we had some problems here with mocking, with API mocking. And this is a problem that's been here for a long time. And I'd like to explain the problem and show you a new feature of the famous MSW library called MSW source. What is it about? So we have a backend API. And the backend returns this shopping cart information, products information with a price. Note that price is a number. Now, I don't want to work with real backend. I don't do end-to-end test. So I'd like to mock it. So this is how my test would look like. I'm importing from MSW, a very popular library that is mocking HTTP request. And I'm about to check that when displaying a cart product, the price is displayed correctly. For a start, I need to mock the backend, right? So I'm telling it, hey, MSW, if someone calls this, don't let it go to the backend. Mock it and return this payload. See, price is a number. Awesome. We render the cart, we fetch the price, and we ensure that it's indeed a number that equals to 50. Great. I think that this is what 80% are doing, or it's a quite common technique, right? MSW is the most downloaded library in the mocking era. But now, price has changed on the API side. It's not longer a number. It's now an object. There is a change, or maybe it was there from the beginning and I missed that information. What will happen to my test? Sadly, they will pass, right? Because I have a mock, and my mock will render a number, and my test fetch a number. And that's the tragedy of, well, of course, production is down, right? Because in production, I will meet the real API that returns something else, and I will realize it too late. That's the tragedy of mocking, right? It traps you in your own world when coding, but then you realize things later on. This is known as the contract problem. And there are many tools and approaches for it, but I think that it's a good starting point. You want to bet on OpenAPI. Most, or if not all of the reputable players in this market, use OpenAPI to drive this workflow. They demand the API to produce document that's called OpenAPI that explains it. And then based on it, all the features that we're about to see are even possible. So this is a new feature from this year. It's called MSW source. And it will going to make our life easier here. How? This is considered a monorepo. We have the backend. We have the front end. Now we need a new folder. The backend contracts. Some place where the backend could put an OpenAPI document. By the way, it can be NPM package or Artifactory, whatever you like. Here it's a monorepo. And now this is the OpenAPI. See, we can define here the route that returns products, responses, and I can also return examples. To make the consumer easier, I can share examples of what type of information might be there. So how does it make our test better? Let's see now how the same test, only this time with MSW. Cool. For a start, I import from OpenAPI. Then I'm importing the OpenAPI document itself. And in before each, we call from OpenAPI. This one will generate all the backend responses automatically based on the OpenAPI. So it's not longer from my imagination. It's coming from a document that was provided by the API. How does it look like? On the right side, you have the OpenAPI. In runtime, MSW looks at a request. There is a request to this route. It searches in the document. It finds such a route. It looks if there is an example. If there is an example, it will return it. If not, it will just try to come out with something sensible. So this is what will be returned in my testing automatically. So now I'm bringing the server up, and I can write my test again. Same test, same goal. Only now, in the beginning, I want to go to the OpenAPI document and change, specifically put a price there of 50, because I want my test to be explicit, and avoid relying on external documents, render the cart, and now, again, I try to check that it is indeed 50. So what is the difference? Well, the big difference will happen when I run the test, and happily, it will fail on my machine, not in production, for the first time. I appreciate the screen here. Awesome, that's helpful. See, it tells me, yeah, I swear that it tells me, hey, you try to search for a number, but we have some problems with the screen, but you got an object. Well, where did this object come from? From the OpenAPI. So it's kind of me collaborating with the API offline without sharing, without creating a pricey shared environment. In other words, my test failed thanks to information that is coming from the backend that allows me to realize failures easier. That's the beauty of MSW. And there are other techniques, but I'm short of time, and I'd like to say, you see, I'm going to skip some slides. Last minute, I just want to recap. This was the last features, but I want to say a few closing words and suggest that it's way beyond features. I think that there is now a real paradigm change in the testing space. And why? Because, see, test used to be a risk issue, right? We have a human writing code, and if there are no tests, what's the big deal? Well, it might last, a sprint might last 10 or 30% longer, there might be a little bit more bugs. Organization could handle this. It was bad, but it was not catastrophic. But now, testing is a scaling issue. Because now that we expect agents, or at least agents help human writes a lot of code, having not tests guarding them means that we have to put, or we have tons of PRs piling up, or a lot of humans reviewing each and every line, and we lose the entire idea of having agentic testing. So now more than ever, investing in realistic techniques that runs early in the browser and check the API risk and have a very efficient agentic testing pay off more than ever to you, because they buy you a very precious time that allows you to have more agents write code or spend time with your kids or at the gym. Anyway, my friends, I think that by now, if I did my job right, I know, if I did the last slide, I promise, if I did my job right, your testing framework brain is now updated to 2026 Q1. Enjoy your new workflow. It was a pleasure. Thank you very much.